Okay, in this video, we're going to cover scientific notation. What is scientific notation? What do we use it for? Essentially, scientific notation is a way to make very long or large numbers, or maybe very, very small numbers, more manageable. So how do we read scientific notation and how do we write scientific notation? Those are the two things we'll cover right now. So how do we read scientific notation? Okay, well, first things first, I have usually 2 to 4 or so numbers in the front, and that's how scientific notation always starts. Then there's usually a times 10 that follows, and then there is a subscripted number on the top right that we will also read, and that is kind of the basis for scientific notation. It will always be 2 to 3 numbers times 10 raised to a certain number, and it may be negative and it may be positive, but that's how we read scientific notation. Now, how do we write scientific notation? First things first, I'm going to get a huge number or I'm going to get a small number. And these are really a lot of digits to work with, and for scientists, we get lazy, so we're going to have a way to shorten it. So, for example, let's start with this. What is this? 1,234,567,890. To write scientific notation, I'm first going to look at the first 2 to 3 digits. And in my class, for this AP class, we're going to look at the first 3 digits. And that is the first 3 digits I'm going to write, 1, 2, 3, and I'm going to put a period after the first digit. Okay, just like they did right here in this example, they did 1.24 for both of these examples. We're going to write 3 digits and put a period after the first digit. After that, it is always followed by times 10. Okay, no matter what it is, you do those first 3 digits, then times 10. The final thing is we got to figure out what goes in this top right, this subscripted area. This is determined by looking at the number and starting from the far right decimal point, moving over and counting how many times it takes to get to the new period slot, which we made right here. So I'm going to count how many times it takes. That takes 1, 2, 3, 4, 5, 6, 7, 8, 9. So for scientific notation, the subscripted number is going to be 9. Ultimately, 1.23 times 10 to the 9th right here represents this number. Now, obviously, we're missing 3, 4, 5, 6, 7, 8, 9 digits right there, or those numbers. We're going to live with that as in science, and we're going to shorten it by rounding it. Okay. So let's look at this next one. I'm going to do the same exact thing I did for the first one, and I'm going to write the first 3 digits that I reach after I hit this decimal point. So there are all these zeros, and I'm going to do those first 3 digits. So I'm going to do 1.23 again. Then, as always, I'm going to do times 10. And I'm going to do the same thing, but I'm going to start from the left, and I'm going to end up between the 1.2. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8 digits to the right to get to that new digit point. Okay. The one difference is I'm not going to have this to the 8th power, but rather to the negative 8th power. Now, that doesn't mean this number is negative, because it obviously is not. It's just a very small number. It's not negative. What that negative 8 tells me is it's just a small number, and I had to go make it a decimal. So this is how we write scientific notation for a large number with a positive subscript, and when it's a very small number, we'll put a negative subscript. Okay.